Buckle up, space explorers. Measuring our cosmic neighborhood is mind-blowing. Imagine trying to measure your backyard with a ruler. It works, but for galaxies, forget it. Distances between stars are so mind-bogglingly huge that using miles or kilometers becomes silly. We need bigger units like the Astronomical Unit, or AU. Think of it as a cosmic yardstick, perfect for measuring within our solar system, but even AUs have limits. For those truly epic distances, we blast off to light years. Imagine a beam of light racing away from Earth for a whole year. That's 1 light year. It's a unit that blows AUs out of the water. And for the absolute whoppers, we have parsecs. A parsec is like a light year, but even vaster. It's the distance at which a star's position would seem to shift ever so slightly as Earth orbits the Sun. When dealing with the mind-blowing scale of the universe beyond parsecs, astronomers use a different approach called redshift to understand vast galactic distances. With astronomical units, light years, parsecs and redshift, we can finally start to grasp the true scale of the universe, a place where even the biggest numbers feel small. Now let us look closer at these cosmic distances. Ever wondered how big our solar system is? Forget kilometers or miles, astronomers use a special ruler, the Astronomical Unit, or AU for short. It's not quite the exact distance between Earth and the Sun, but close. Think of it as the average, like the halfway point between Earth's farthest and closest points in its orbit. In 2012, scientists even gave the AU a super precise definition: 149,597,870.7 kilometers. Whoa! But why AU? Our solar system is vast and kilometers just wouldn't cut it. Using AUs lets us easily compare the distances between planets, asteroids and comets. Imagine saying Pluto is 39.5 AU from the Sun. That sounds much more manageable than 5.9 billion kilometers, right? So next time you're gazing at the stars, remember they're not just a pretty sight, they're all a specific number of AUs away, making our cosmic neighborhood a little more relatable. And who knows, maybe someday you'll use AUs to measure the distance to planets in other solar systems. Miles just don't cut it in space. Our stellar neighbors are separated by distances that would make your head spin. Enter the light year, the distance a light beam, the universe's fastest traveler, races in 1 year. That's a whopping 6 trillion miles or 9 trillion kilometers. Basically, a cosmic ruler for interstellar distances. Imagine the nearest star system, Alpha Centauri. At 4.3 light years away, it sounds much more manageable than 25 trillion miles, right? Light years also put our solar system in perspective. The Sun is a mere 8 light minutes away, meaning the sunlight you see left 8 minutes ago. That's the mind-blowing thing about light years. When we look at distant stars, we're seeing them in the past. So the further we gaze, the further back in time we travel. Think of it like a cosmic history tour, all thanks to the incredible speed of light. Buckle up, space explorers, because the universe's vastness becomes a little less daunting with light years. A parsec is a unit of measurement used in astronomy to describe vast distances in space. Specifically, it's the distance at which one astronomical unit, the average distance from the Earth to the Sun, subtends an angle of 1 arc-second. In simpler terms, it's equivalent to about 3.26 light-years, or approximately 19 trillion miles. Parsecs help astronomers understand the immense scale of the universe and the distances between celestial objects. Imagine staring at the night sky. Those twinkling stars are mind-bogglingly far away. Regular kilometers just won't cut it for these cosmic distances. That's where astronomers use light years. The distance light travels in a year, which is a whopping 9.5 trillion kilometers. But even light years get small when you start talking about galaxies. Enter the parsec, a unit based on stellar parallax, a tiny wobble in a star's position. A parsec is about 3.26 light years. Now, for truly gigantic distances, like between galaxies or across vast galaxy clusters, we jump to gigaparsecs. 1 gigaparsec is a billion parsecs, or a mind-blowing billion times the distance light travels in a year. That's a unit that lets you truly grasp the immense scale of the universe we inhabit. So next time you gaze at the stars, remember that those celestial wonders could be billions of parsecs away. Ever wonder how we measure the mind-blowing distances in space? It's all thanks to a trip called redshift. Imagine the universe like an expanding balloon. As galaxies move away from us, the light they emit gets stretched, just like the balloon stretches. This stretch shifts the light towards the red end of the spectrum, hence the name redshift. By measuring this shift, we can calculate an object's distance and even its speed through the cosmos. Pretty cool, right? That's just a glimpse into the cosmic measuring toolbox. We've gone from AU in our backyard to light years for stellar neighborhoods, and all the way to parsecs and redshift for those mind-bogglingly distant galaxies. But the universe keeps getting bigger, the more we learn. So, if you're ready to blast off on more cosmic adventures, hit that subscribe button. Don't forget to like and share this video to spread the knowledge of these incredible units. And leave a comment below. What other mind-bending questions do you have about the vastness of space? Let's explore the universe together. Remember to take care of each other and always be looking up.